We're going to take a look at the mid-segment theorem, okay? And we'll talk a little bit about what these segments, they have some special properties in terms of how long they are and comparing them to other sides in the triangle. So a mid-segment is basically a segment that connects the midpoints of two sides. That's it. A mid-segment is a segment that connects the midpoints of two sides of a triangle. Okay, let me try to sketch a mid-segment, and I want to see if you can tell anything special about it. Okay, so we'll draw a triangle, then we'll draw in a segment that'll connect the midpoints of any two of the sides. Okay, it doesn't matter which two. Let's draw just any kind of triangle. Okay, you want to try to mark the midpoints pretty accurately. So let's do that one, and let's do that one. Okay, now if I draw a segment connecting it, that's a mid-segment. Okay, so that line in red, that's a mid-segment. Anybody think they can tell anything about that segment? Let's label some of these points. There's actually two special things about segment DE. Yeah?
It's scaled down from DCE, it's scaled down from ACB.
Okay, so you're arguing maybe that these are similar triangles? It could be. Okay, we haven't studied similar triangles yet. We will be looking at those later on. We've only done congruent triangles, but maybe triangle DCE is a smaller version of ACB. Could be. I think you are right on that. And there's a couple ways you could justify that if you know a little bit about mid-segments. Certainly, they both share an angle C, but they'd have to share one other angle for them to be similar, but they do, because of what I'm hoping somebody will say. Yeah?
DE doesn't intersect with AB.
Yeah, so it's parallel. Yeah, it's good. It's parallel. So that's the key that would actually prove these triangles similar, not congruent. We're not talking about that today, but that is a good point. Because you have two parallel lines cut by a transversal, so the corresponding angles are equal. And of course, that angle matches itself. That's reflexive, so you have triangle similarity here.
Would that also be congruent because we can prove angle almost?
No, they're different sizes. One's a smaller triangle, one's a larger triangle.
They're the same angle degree?
Yeah, angles can be the same, but they are different sized triangles, so no congruence here. And we can prove that they're not congruent from the second fact. Okay, so DE is parallel to AB. That's something special. Anybody know something else about DE? Something more about its length.
It's half.
Half of what?
AB.
Yeah, it is. It might not, at the moment, okay, it might not look like it, but if you take a copy and you kind of put it up here and over here, okay, we didn't draw it perfect, but if I had measured those, I think E actually should be a little bit, you know what, in fact, why don't we move it out? I think it's supposed to be, does that look better? A little bit further over. Now that should make it a little longer. Okay, but if you measure your midpoint accurately, it should come out to be half as long as the side it's opposite. Okay, the side it's parallel to. Let's see if that's a little better. So you get that, and put that about there. Yeah, that looks better. Yep, so it's about half as long and parallel to that third side. And that'll happen wherever you draw a mid-segment. Okay? We'll write that as a theorem in a second. Okay, let's do a coordinate proof. Okay, let's show that the mid-segment Mn is parallel to Jk. Okay, so how would you show two segments are parallel? What do you have to find? Yep. You got to find their slope. So we'll find the slope. And then to prove it's half as long, well, we'll use the distance formula on Jk, get the length, then do the same thing on Mn, and see if it's half as long. All right, let's start with the slopes, because that's quick. All right, so let's find the slope of segment Jk. How do you find slope? If you already have 2 points, you could use y2 minus y1 over x2 minus x1. But, what's that?
There's another way.
Yeah, if you got it drawn, there's another way. It's 2 words, something over something.
Rise over run.
Yeah, just find the rise over the run.
1/3.
There's your rise. There's your run.
You can simplify that.
What's the rise before we simplify? 2. What's the run? 6. See, 1, 2, 3, 4, 5, 6. Yep. And if we reduce it, we get a slope of 1/3. So if Mn is going to be parallel, its slope also has to be 1/3. Okay, let's check. Okay, the slope of Mn. There's where the start, stop. There's my rise. There's my run. What's the slope of Mn? It's also 1/3. Up 1, right 3. What does that prove? If they have the same slope, Nick, that proves that they are what's equal? No, not the length. Slope's not a length. What does that prove if two segments or 2 lines have the same slope? Oh, Morgan? Look at that. 2 things have the same steepness. Look at Jk and look at Mn. They are what are the 2 things we said about a mid-segment? Let's go back and take a look. So a mid-segment of a triangle. The directions were to show that it's parallel and it's half as long. So those are the, and we kind of did a rough sketch of that here. So what did we just show out of those 2 things? What did we just show was equal? The what? The slopes. Okay, we just showed the slopes are equal. So what does that prove? 2 things have the same slope. They are parallel. Okay, so we've shown the first half of what they wanted. 2 things have the same slope. They're parallel. Make sure you know how to find slope. Okay, that's not really something we reviewed a lot this year because it's taught in Algebra 1. But you still need to know it. And most people seem to rise over run. They knew that, so that's good. All right, now the harder part is the distance formula. That formula is a little more complicated. Okay, so let's find the distance of segment Jk, or length. Let's write it that way. Length. Okay, how does that formula start off? I always like to write something down so I don't forget to do it. Yeah?
y2 minus y1 over x2 minus x1.
Okay, that's your slope.
Oh my god.
Yeah.
I'm so...
y2 minus y1 over x2 minus x1 is slope. So we got that.
X2 minus x1 squared plus y2 minus y1 squared. That square root.
Perfect. That's exactly the formula you want.
Write that down.
That's your distance formula. Okay, the distance formula, it's just the Pythagorean theorem rewritten. So if you know the Pythagorean theorem, that's what this is. Okay? So now we just have to plug in our coordinates. But that's exactly what you want. First thing I always do is write down the square root, put parentheses with a minus, square it. And now you just have 4 things you need to fill in. Okay, let's go look at the 4 numbers. x2 minus x1. Okay, let's look at JK. Doesn't matter which one is the first one and which one is the second one, whether you measure the length from J to K or you measure it from K to J. It's the same length. Okay? So let's call this x1. That'll be y1. Let's call that x2 and the other one y2. So x2 minus x1. 4 minus negative 2. Okay, so be careful with that. So x2 is 4, x1 is negative 2. Any questions why I have 2 negatives right there? One's
Negative.
yeah, the number is a negative and the formula has a negative. Okay, it's a mistake a lot of people make. Yeah, it'll become a plus. Now we got y2 minus y1. 5, 3. Okay, fill those in. 5, 3. So as Connor just said, minus negative 2 becomes plus 2. So that's 6 squared. 5 minus 3 is 2 squared. 6 squared, Jacob, how much is that? 6 times 6? 36, yeah. And then 2 squared? 4. Okay, so add those up. And we get the square root of 40, which can be reduced. Okay, so the way you reduce a square root, or one way to do it, is you got to break it up into 2 numbers that when you multiply them together, one of them is a perfect square. Anybody tell me a perfect square that goes into 40? Yeah? Yeah, so you can break 40 up into square root 4 times square root 10, and then the square root of 4 is how much? 2. Good. 2 square root 10. Okay, reducing roots is probably something that should have discussed in Algebra 1 as well. Okay, so that's the distance of the length of JK. What am I hoping the length of MN comes out to?
Half that.
Half that. Okay.
I've got no.
Well, that's actually an easy number to take half of.
And
Not 10, but
2 is 1.
that number is 2 times the square root of 10. So what's half of 2 times the square root of 10?
It'd be 1 times the square root of 10.
1 times the square root of 10, or just the square root of 10. Right? So that's what we're hoping we're going to get. Right, let's see. Set up our formula. So length of MN. Okay, parentheses plus parentheses. Write down our formula. And I tried to draw M and N so the coordinates would be pretty easy to figure out. If they weren't given to you, you could always use your midpoint formula and find it. All right? In fact, it might be just as quick that way. 6 minus 2 is 4, and then take half. That's 2. 3 minus 1 is 2, and then take half. That's 1. Okay? So that's the midpoint. And visually, that looks correct. 2, 1. Okay, N. Let's find the midpoint. 4 plus 6 is 10. Take half of it. That's 5. Does that look right? Yep. 5 minus 1 is 4. Take half of it. That's 2. Up 2. That looks good as well. This time, let's call that x2, y2. And x1, y1. Okay, let's see what we get. So x2 is 5. x1 is 2. Okay, let's look up y2 and y1. y2 is 2 and 1. Okay, Nathan, what's 5 minus 2?
3.
Squared?
6, no, 9.
9, good. Okay, 2 minus 1 is 1 squared. is 1. And we get the square root of 10. The other one was 2 square root of 10. So we just proved that mn is half as long as jk, or jk is twice as long as mn, and they're parallel. That doesn't prove the theorem in general. It proves it for that specific triangle only, okay, because we used all numbers. Okay, any question on that? Yeah?
Since the slope of the mid-segment was half of the slope of the other line, couldn't you have just been able to say that they were halves of that?
Careful, say it one more time.
The slopes of the line, one was half as big as the other one.
The slopes were identical. The slopes were both 1 over 3, 1 over 3.
Yeah, but like at first the other one was 2 over 6.
Yep, that's still 1 over 3 though. Yeah. Yeah. So just because you know the slope of something, that doesn't tell you length. Because I could give you 2 lines that have the same slope, but one is 5 times longer than the other, or 5 times shorter. So just because if I just describe slope to you, you have no idea what length is. For example, say I said to you, I have 2 vertical lines. How much longer is the one on the left than the right? You don't know. You know they have the same slope, because they're 2 vertical, or 2 vertical segments, I should say. But without knowing a little bit more information, other than the fact that they're vertical, you don't know how long they are.
It works in this situation because, well, it doesn't really work.
Yeah, it doesn't. You got to know more than slope to figure out length. Yeah, they're two separate things. Okay, any other questions on that? Good thoughts? Good. Okay, so here's the kind of the formal definition of the mid-segment theorem. So it says the segment that connects the midpoints of 2 sides of a triangle is parallel to the third side and half as long. Okay, so I found the midpoint of AC and BC, marked those points D and E, connected it with a segment, and that proves, well, this theorem says that DE and AB are parallel, and DE is half the length of AB. Or you could say AB is double DE. You could say it either way. It means the same thing. Okay, but that's called the mid-segment theorem. Okay, and it's on page 288. Okay, any questions on that? Okay, so far we haven't drawn the other mid-segments in, but in a second we'll take a look at what happens if we draw in the other segments. Okay, we actually can create kind of another triangle inside the bigger triangle. We'll take a look at that. All right, so in this example, I'm telling you that UW and VW are mid-segments. I want to find the length of UW and RT. Notice how I wrote it, too. When I wanted to talk about the segments, I put the bar over it. When I wanted to talk about the length, I didn't put the bar over it. I will test you on that on the midterm. Okay, the proper notation for stuff. All right, so let's find UW. Okay, anybody have a thought how long UW would be based on the theorem? Yeah? Yeah, it would be 6. We know that UW is half as long as the side it's across from, and it's also parallel, but that we didn't need to know here. And we also want to find RT. Someone else think they could tell me the length of RT? Kira?
16.
Yeah, it's 16. RT is double the length of VW. Okay? It's also parallel, but we don't need that here again. All right? Even if they didn't give you the description up above, just looking at the diagram, how do you know that UW and VW are mid-segments? Just looking at the diagram. Yeah?
They show that SW and TW are congruent.
Yeah?
That means SW is half of ST.
Yeah. Yeah, you got two congruent segments, which proves W is right in the middle. Right? The only way that a segment can be divided equally into two parts is if W is the midpoint. It has to be. Same thing with V. RV and SV, those are congruent. And then RU and TU, those are congruent. So even without the description, you know you have mid-segments here.
Mr. Hager, say we took VU and did one of those. Would that triangle in the middle be a smaller scale of the big triangle?
It's like a similar one?
Yeah.
Maybe we'll talk about that later on. I don't want to try to get into that right now, but I'm not gonna give you a direct answer on that.
Okay.
There are some things about that triangle in relation to the bigger triangle. We're going to tie in a perimeter of the small triangle and the big triangle, which if you understand that each side is half as long, it pretty much tells you what the perimeter of this small triangle would be compared to the big triangle. Right? But yeah, there's all kinds of things you could look at here, whether you have congruent triangles or similar triangles. There's a lot in that diagram to look at. And you got all kinds of parallel lines cut by transversals. And so you've got angles that are equal, okay, all over the place, corresponding angles, things like that. Alternate interior angles. Okay, we won't get into that too much right now. All right. So next we're going to try to prove part of the mid-segment theorem. We're not going to prove it 3 times, which is what you'd have to do, prove it for each one. But we'll try proving it for one segment. Now the key that makes this proof either easy or difficult is where you place your triangle. Okay, so we've talked about trying to place your triangle in a good spot that makes the coordinates easy to work with. So one coordinate I put at the origin, 0, 0. That's always an easy coordinate to work with. Right, now we've got to come up with the coordinates for the other vertices. Now, keep in mind, we're going to be working with mid-segments. All right? So if you're going to be finding a mid-segment, that's what's in the middle. It's the average of 2 points. It's the average of the x's and the average of the y's. How do you average 2 things? What do you do? Okay, so if you're averaging 2 things, then divide it by 2. What kind of numbers can you divide by 2 easily? Even numbers. Okay? So what we want to do is think about the coordinates for C and for A, or C and B. But we want to use even numbers. For example, you wouldn't want to use x and y. Because now when you add them up, you average 0 and you average x. Now you're going to have x over 2 when you average them, or 1/2 x. Now you've got to deal with a fraction. So I think our book, they don't even use x and y. They use a and b. Okay? But instead of a and b, what could I put in front of a so that when I average it with 0, I get a nice answer? Because the average of a and 0, that's 1/2 a. That's going to be hard to do the proof that way. Yeah? 2a. You can call it whatever you want. A could be, a is a variable. So I can make this x value anything I want by controlling a. The 2 just makes the averaging come out nice. That's all. How about b? Similar idea. What do you think I could put for b to make the averaging come out nice? Yeah, let's make it 2b. Again, b can be anything I want. fraction, decimal, positive. Can't be negative because we're up in quadrant 1. But I can control the height by letting b be anything I want. The 2 just makes the averaging come out nice. You could also use 4. 4, 6, 8. But then now your number is getting kind of big. 2 is the smallest number that you can do an average with. 2 things and have it come out nice. Okay, now how about our coordinate for b? Maybe let's start with the y value. What's the y value going to be for coordinate b?
0.
It's going to be 0 because it's on the x-axis. You haven't gone up or down. Good. Now, what would be a nice number we could have for the x value? Something that we can do averaging with, but it doesn't necessarily have to be the same as the x and y value of point C.
2c.
Yeah, it could be something different.
Because, well, you also have to look at that it's not even a right angle, so it can't be the same x value.
Yep, so sometimes when you have, if you had a triangle that has a right angle, then this point and this point have the same x value. So whatever x is, they share that. The y's are different. But we don't have that in this case. Okay? So all the points could be different. So that's a good way to label your points. And for most people, that's the hardest part of this proof. Figuring out how can I label my coordinates so I make the work easy. But that's how you want to start. All right, so now we'll go through part of the proof. Let's draw in a mid-segment right there. Okay, I just estimated it the best I could. What would be the coordinates of D? Let's start with the x coordinate. Connor?
2d.
Well, that's the y.
No,
that's the y coordinate.
y coordinate, so it would be 2. I said 2d because that's not on the same. It's not on 0, 0 or.
Right, but D and E are midpoints of 2 other points. So we don't need new letters now. We can use the old points we have.
2n.
How do you find D if it's a midpoint?
Half. It's half of AC, so you would use.
Well, careful, slow down. DE is half of AB, segment length. But what I want is the coordinate
D
for
is the
D.
midpoint of segment AC.
So how would you get D? Exactly, it's a midpoint.
Half the distance of, it's placed on half the distance of AC.
That's true. So how do I get point D? What is it? I want the exact
It's a
coordinate.
midpoint.
Right, but I want its location. I know it's a midpoint. Can anyone tell me, how do you get the location of it? Like what, comma, what? What are the 2 things that are going to go here? Remember, how do you find a midpoint? If you have 2 points and you want to know the middle, what do you do? Average, yeah. You add them up and you divide by 2. Okay? So what would be my x value for point D? A. Okay? It's exactly at A. Why? Well, this x value is 0. This x value is 2A. What's halfway between 0 and 2A? 1A. Okay? How about my y value? B. This y value is 0. That y value is 2b. What's halfway between? 1b.
Why are you making this more complicated? Well, I made it more complicated than it needs to be, right?
Well,
Pretty much.
you were trying. That's good. That's good. At least you're thinking.
The wheel is spinning.
All right. Let's find the coordinates of E. Let's start with the y value. That one's going to be easier. B. And it should be B, right? If this line is going to be parallel, I would hope that these y values would match because I want the slope of that to be 0. That's a horizontal line. And the bottom line is also horizontal. Okay? Now, how about the x coordinates? It's not going to be quite as nice, but how would we get it?
Just be AC.
Close, not a times c.
A plus C.
Yeah, it's a plus c. Okay, the reason is if you wanted the x value, you'd take 2a plus 2c and find the average. Add them up and divide by 2. Well, what happens is the 2's cancel out, and you end up with a plus c. All right, so now we've got our coordinates, and notice D and E, no fractions, because we picked intelligent numbers for the coordinates for A, B, and C. All right? So now let's start with the slope. Okay, we can't count rise over run here because we don't really have a grid. So we're going to have to use the formula that somebody mentioned earlier. Okay, y2 minus y1 over x2 minus x1. Okay, can somebody fill that in for me using that coordinate and that coordinate? What's going to go in the top? Yep.
B minus B.
Good.
And
A minus B.
A minus A plus C.
Yep. And A minus the other coordinate, A plus C. Okay, Katrina, what do you get in the top? You get 0. And in the bottom, you're going to get A minus A, because you distribute that negative out. So it's A minus A. What else is left in the bottom?
Just negative C.
Negative C. Doesn't really matter what's in the bottom, though. The slope is 0. DE is a horizontal line. Slope 0. Okay, let's find the slope of AB. Okay, same idea. Use your formula. y2 minus y1. It's 0 minus 0 in this case. And technically, we can stop there. It doesn't matter what's in the bottom. You have 0 in the top. 0 divided by anything is 0. Okay, but if you wanted to fill out the bottom, it'd be 2c minus 0. 0 divided by 2c. Okay, so what did we just prove? DE and AB are parallel. Okay, we just showed that they're parallel. Okay, now we're going to show their lengths. The length here, we don't really need the distance formula because they're horizontal. So we can actually make it a little easier. We can use the formula for finding the length of things on a number line. Okay? All you have to do if you're on a number line, let's say you're at 2 and 8, and you want to know the distance between 2 and 8, just take the absolute value of the end, 2 minus 8. So, or 8 minus 2, it's 6. Okay? So you just have to subtract your endpoints. Okay, so let's find length of DE. Length of segment DE. Okay, the B's don't matter. The B's are the Y values. We already know they're at the same height. We just want to find how far apart they are on the X's. So take A plus C minus A. So what's the length of DE? Olivia? C. DE is C units long. Okay. So I started at A. I ended up at A plus C. What's the distance between A and A plus C? C. Added C. Right. Now let's do the same thing. Let's find the length of the bottom. So length of AB. Segment AB. If I didn't want to write length of, I could just write this. That'd be quicker. And then write my answer. Okay, so on segment AB, where do I end up at for an x value? Oh, Luke?
So on what point?
What do we end up at for an x value on segment AB?
So it'd be half A.
Just the location. So I start here, I end here.
Okay.
Yeah. Where do I end? What's my x value?
It'd be C, and the Y would be 0, right?
The y is 0, but what's the x value of point B?
Oh, point B, 2C.
2C.
I thought you were trying to find the point.
So we end at 2C. Where did we start?
0.
We started at 0. So what's the length from 0 to 2C?
C.
It's like if I said, what's the length from 0 to 8? You wouldn't take half of it.
It'd be 2C.
2C. Got it. So from 0 to 2C, that's 2C units long. So we proved that DE is half the length of AB. And the reason that this proof is better than this one, the first proof, only applied to the triangle that had those exact vertices. Okay, the proof we just did applies to any triangle, because A, B, and C could be any numbers you want. Okay, so it's a more of a generic proof. Applies to any kind of triangle. Okay, any question on that? I definitely think that's the kind of problem to really get it and sink in. You kind of have to go back and do it again. Kind of watch it again, go through the steps. Kind of easy when someone guides you through it, but that kind of proof to do on your own, especially the vertices, is kind of hard. Especially if you don't label the vertices correctly. You're going to have fractions in this whole thing. And then that's just going to complicate the proof even more. Okay, so at least we avoided all the fractions. All right, so example 4. What I've done is I've graphed the midpoints of the sides of a triangle. This is not the actual triangle. These points mark the midpoints of some triangle that's bigger. My goal is to figure out the coordinates of the vertices of that bigger triangle. Okay, so first thing I'll do is I'll just connect them. And again, think of this as the smaller triangle that's inside. There's a bigger triangle here. I want to know the vertices of the bigger triangle that would create this mid-segment triangle. How can I find that? Okay, I could write down the coordinates of the midpoints. And there is a way to do this more algebraically, but I think we could do this one visually. We can actually use the grid and draw things. And that will help us.
Oh, is it the smaller triangle?
That's the smaller triangle that would be inside the bigger one. I want to find the coordinates of the bigger one.
They share n.
They share n?
Point n, or they can share any point only
What would share?
for midpoints.
So you're thinking, so here's your big triangle, right? Here's your small triangle. Basically, what I gave you was the one inside. I want these three vertices.
Well, how do you want it? Because there's many ways of doing that.
Any way we can figure it out.
You could have n as one of the vertex and MP be the mid-segment.
So you're saying n is a vertex of the bigger triangle? Let's go back. So remember, my bigger triangle looks like this. The smaller one is inside.
Well, you could also...
The vertices of the smaller triangle are not the same as the ones of the bigger.
You could do it... I see how to
Anyone have another thought?
If,
Yep.
since those lines are like half the length of the
the actual size of the triangle,
Mhm.
what you do is you just multiply by 2, find the lengths, and then you make those lines run through the midpoints.
Make those lines run through.
So you find the length of the smaller ones.
Let's do one of them. Go ahead, pick one.
And then,
Okay, so we got MN. Let's make a copy of it. Okay, so I got MN.
and you find the length of it, which looks about to be like,
Well, we could use the distance formula.
yeah.
Yeah.
And then you multiply it by 2.
Okay, so actually I can just do that visually. Okay, so now I've multiplied it by 2.
And you have that line run through. You have that line run through either one of the midpoints. I think it goes through M, so that line will run through M, be an angle there. No,
Like that?
it goes through L, sorry.
It goes through
It's
L.
Parallel to.
Right. Goes through L, and it goes through L, that segment I just drew, right at the middle. Okay? So I just created, in fact, let's say even I didn't have a way to measure it. Let's just draw a segment, a really long segment, all right? As long as it goes through L, okay? And watch what happens. So I got to go up 1 and right 3. So up 1, right 3. Let's go up 1, right 3. The key is the segment that goes through L is parallel to MN. Okay? If you wanted to measure it perfectly, you could, but you don't need to. Because watch what happens. Okay, now do it again. Pick another side. Let's draw NL. So that's up 2, right 1. So we're going to go up 2. And which point am I going to go through if I'm looking at N?
You're going to go through M.
L.
You're going to go through M.
I'm going to go through M. Okay? NL is going to be half as long and parallel to some other side that goes through M. So up 2, right 1. Up 2, right 1. Up 2, right 1. Let's make another one. Okay, going through the points. And now look what just happened. Those two lines crossed at a point. That point, I'm probably a little bit off, but it's pretty close. That's one of the vertices of the bigger triangle. How could I find the other two?
Just draw from
Do it in green. So how could I get the other two vertices?
that red dot on top. Well, you already see it almost. Just could do up 2 over 1 on, it has to be a negative line.
Okay, so it does have to have a negative slope. Look at
So it's
ML.
going to be up 1 over 2.
Is it up 1 and over 2 or down 1? Well, I guess it depends on which way you're looking at it. I always look at it as I go down and right or up and right. Okay? So somebody else tell me the steps to figure that out. Besides, you're doing good, Connor, but let's just try to get someone else. How can I get that third side in there? You think a little bit. You're going to be a little creative with it. We've already done it for 2. Yep.
You just go up 1 over 2 from the point N.
Yeah, from N. You want me to go up 1 and over 2?
Up 1 back 2, I guess.
So we're going to be parallel to ML, right?
Yeah.
So I would think of it as down 1 and then right 2.
Okay.
So if, as long as you think of it the right way, but down 1, right 2, down 1, right 2.
You kind of basically already got the points out of this. It's
Yeah.
gonna go through one of the points anyway, so.
Draw in that third segment, right about there. And now let's look at where they all cross. Here and here. So I just found the vertices of my bigger triangle. Okay, so I might ask you to do something like that on a test. Okay, it could be a problem similar to this. We didn't quite discuss exactly how to do it, but if you understand the idea of mid-segments and drawing in the lines, you can figure it out. So let's write our coordinates. Denver, let's call this A, B, C. What's the coordinate of A? Yep, 1, 1. Okay, let's look at B. James, what's the coordinate of B?
7, 3.
Yeah, looks like 1, 2, 3, 4, 5, 6, 7, 3. And the last one, C, looks like 3, 5. Okay, certainly other ways to do it that are just algebraic or calculation-based rather than drawing. But I think the drawing one was easier this time. Okay, just using a grid. Okay, any question on that? All right. So what do you think is going to happen here? I've drawn in small triangle, that mid-segment triangle. So DE, EF, and DF are all mid-segments. And I want you to find the perimeter of triangle DEF. How do you think that's going to compare to the big triangle? Yeah. The perimeter of the small triangle is going to be half the perimeter of the bigger triangle because each side is half as big as the one across from it. All right, so let's find DE. Okay, so Justin, what's the length of DE? So we know DE is parallel to CB, but it's also how long compared to CB? Not a third. That has to do with the medians. Half. Right? So what would DE be? 7.1. Okay. Let's find EF. Okay, EF. How about Rose? How long would EF be? Yep, it'd be 5 because it's parallel to that third side and half as long. And lastly, DF. How long would DF be? Yeah.
5.
Yeah, it'd also be 5. Based on that, what kind of triangle is DEF? We don't have to know that here, but it is on the midterm. It's isosceles. Yep. So what's the perimeter of triangle DEF? Triangle DEF, yeah. 17.1. So now if I asked you quickly without thinking about all the work and adding up all the sides again, what would you do with this number to find the triangle ABC's perimeter? Yeah, just double it, 34.2. Okay? So the perimeter of a triangle formed by connecting the midsegments is half the perimeter of the original triangle. And hopefully that makes sense. Each side is half as long, so the perimeter is half as big. Okay, any question on that one? All right, so let's take a look at our last example. And I'm not going to go through it with you right away. I want you to try it on your own. So I'm telling you that MN is x minus 1, and AB is 6x minus 18. So two things. I want you to find x, and then once you find x, tell me how long AB is. Let's see if you can do that one on your own. If you get stuck, let me know. I'll come give you a hint. All right, so a lot of people figured out the relationship here that Mn is half of AB. Some people did it the other way. They said AB is twice as big as Mn. That's fine too. Either way. Okay? So now what you're going to do is fill in for Mn and AB. X minus 1 is half of 6x minus 18. Okay, distribute out your 1/2. What do you get on the right side when you distribute? 3. Yep. Okay, now we got to get x by itself. Okay. How would you put the 9 on the other side?
Probably X on the other side.
Yep, you're going to add it. Add it. -1 plus 9 gives me 8. And then how do we move that x to the other side?
Subtract X, so it's 2X.
Subtract x.
And X equals 4.
Okay, so now we got x equals 4. Is that what they wanted?
No.
Part of what they wanted.
Then you have to plug it in for AB.
Right, they want the length of AB. So fill in 4 for x. 6 times 4 minus 18. 6 times 4 minus 18, how much? 6.
Couldn't you just we could have done is just subtract 1 from 4 since that's what it is, and then just multiply that by 2.
Yeah, there's other ways to solve it and set it up. But yeah, there's definitely other ways to do it. Sure. Okay, so the homework for tonight, it's on page 290. It's 3 through 8, 12 to 18, those are both all. And then 21, 22, 26, 29, and 33.